Hi, the Science Chef is here again. In this video, you'll be learning about the types of chemical reactions, their features, and examples. Don't go anywhere, I'll be right back. Generally, a chemical reaction is one in which one or two substances undergo a change to form new substances. In other words, every chemical reaction consists of two components, namely the reactants, which are the substances undergoing the change, and the products, which are the new substances formed after the change. There are numerous chemical reactions, but for the purpose of this lesson, we shall be looking at the following types of reactions: combination reaction, decomposition reaction, combustion reaction, displacement reaction, precipitation or double decomposition reaction, reversible reaction, catalytic reaction, and redox reaction. Just as the name implies, a combination reaction is one in which two or more reactants combine to form only one product. Emphasis is on the formation of a single product and can be generally represented as A plus B giving us C. It can occur between two elements, for example, in the reaction between hydrogen gas and oxygen gas to form water, and sodium and chlorine to form sodium chloride salt. It can also occur between a compound and an element, as seen in the reaction between carbon 4 oxide and carbon to form carbon 2 oxide, and carbon 2 oxide and oxygen to produce carbon 4 oxide. Or it can take place between two compounds, like in the reaction between lead 4 oxide and sulfur 4 oxide to form lead 2 tetraoxosulfate 6, and calcium oxide and silicon 4 oxide to form calcium triosilicate 4. You can see that though these reactions occur under different conditions, but the things common to all of them are that they have more than one reactant and only one product. Next is decomposition reaction. A reaction in which one reactant breaks down to form two or more products is said to be a decomposition reaction. It is the opposite of combination reaction and is represented as A, giving us B and C. The decomposition reaction can be catalytic or thermal. When the change occurs in the presence of a catalyst, it is called a catalytic decomposition. For instance, the decomposition of hydrogen peroxide to form water and oxygen gas in the presence of manganese 4 oxide. The manganese 4 oxide acts as a catalyst in the reaction. Meanwhile, the change that occurs in the presence of heat is called thermal decomposition. Example: the thermal decomposition of copper 2 triazonitrate to form copper 2 oxide nitrogen 4 oxide and oxygen gas, and the thermal decomposition of aluminium hydroxide to form aluminium oxide and water. The small triangle above the arrow represents source of heat. So, what is common to the reactions showing on the screen? Yes, you're right. They all have only one reactant and more than one product. Next is combustion reaction. A combustion reaction is said to occur when a substance burns in the presence of oxygen. It can be complete or incomplete. A substance is said to undergo a complete combustion when it burns in excess oxygen or air. For instance, carbon undergoes a complete combustion to form carbon 4 oxide, while a hydrocarbon like methane burns with a blue flame in excess oxygen to produce carbon 4 oxide and steam, which makes it a complete combustion. On the other hand, when a substance burns in limited supply of oxygen, it is said to undergo an incomplete combustion. Example: when carbon burns in insufficient air, it forms carbon 2 oxide, whereas methane burns with a sooty flame in a limited supply of air to give carbon 2 oxide and steam. The sooty flame later gets deposited as carbon. If you compare the two reactions of carbon with oxygen, you will observe that 1 mole of oxygen is required for 1 mole of carbon to burn completely. And when the amount of oxygen available is not up to 1 mole, it results in an incomplete combustion. Same explanation is suitable for the combustion of methane. Next is displacement reaction. In a displacement reaction, a more reactive element displaces a less reactive element from its solution or compound. It is a characteristic reaction of halogens or group 7 metals and also occurs between metals in the reactivity series and is represented thus: A plus BC to give us AC plus B for metals, or A plus BC to give us BA plus C for non-metals. For metals, A displaces B, while for non-metals, A displaces C. Usually, the elements higher in the reactivity series will always displace the ones below them. Examples include the reactions between zinc granules and copper 2 tetraoxosulfate 6 solution to form zinc tetraoxosulfate 6 and copper metal. In this reaction, the zinc metal displaces the copper 2 ion from its solution. This will be confirmed by the change in the color of the solution from blue to colorless, which means that the copper 2 ions have been removed from solution since it's responsible for the blue color and reduced to brown metallic deposits of copper. Zinc ion is colorless in aqueous solution. This explains why the resulting color of the solution is colorless. Also, the reaction that occurs when chlorine gas is bubbled into a colorless solution of potassium bromide. It will be observed that the colorless solution turns brown. This is because chlorine, which is more reactive than bromine, takes the place of the bromide ions in the solution and releases the reddish brown bromine molecule, which changes the color of the solution to brown. Another example of a displacement reaction is the thermite reaction used in welding rail tracks. This reaction occurs when a powdered mixture of aluminium and iron 3 oxide, also known as the thermite mixture, is lit. The aluminium metal displaces the iron 3 ion from the oxide to form molten iron, which fills the cracks between the rail tracks and binds them together when it solidifies. This is possible because aluminum is higher than iron in the reactivity series for metals. Next is precipitation reaction. A precipitation reaction, also called double decomposition, is one in which two soluble reactants combine to form two products, one soluble and the other insoluble or volatile through exchange of radicals, and generally represented as shown on the screen. It is applied in the preparation of insoluble salts, preparation of volatile acids, and also used as a separation technique to remove soluble ions from their solutions. Examples of double decomposition reactions are the reactions between aqueous solutions of sodium chloride and silver triazonitrate 5 to form insoluble silver chloride, which appears as a white precipitate and a solution of sodium triazonitrate 5, and the reactions between aqueous solutions of potassium chloride and tetraoxosulfate 6 Rc to form hydrogen chloride gas and soluble potassium tetraoxosulfate 6. We have treated the concept of double decomposition in details in our video on the preparation of soluble and insoluble salts. Check the link in the description. The next reaction we will be discussing is the reversible reaction. A reversible reaction is one that occurs in both directions, that is, forward and backward under suitable conditions. It is always represented with the forward and backward arrows, thus A plus B giving us C. Most times, for reversibility to take place in a reaction, such must occur in a closed system, especially when it contains a gaseous reactant or product. An example of a reversible reaction is the industrial manufacture of ammonia from nitrogen and hydrogen gases through the Heber process. This reaction occurs at a temperature of 450 degrees Celsius and 200 atmospheric pressure. Another example is between sulfur 4 oxide and oxygen to form sulfur 6 oxide in the contact process, which takes place at a temperature of about 450 degrees Celsius and a pressure of about 2 atm. When the thermal decomposition of limestone occurs in a closed system, at this stage, the reaction will proceed in both reactions. Reversibility is a major condition for a reaction to attain chemical equilibrium, be it in a closed or open system. You will learn more about chemical equilibrium in our subsequent tutorials. Lastly, we will be considering the catalytic reaction. From the name, we can say that a catalytic reaction is one that occurs in the presence of a catalyst. A catalyst is any substance that alters the rate of a reaction and remains qualitatively and quantitatively unchanged at the end of the reaction. In other words, a catalyst does not partake in a chemical reaction. Hence, its mass and chemical properties would remain the same, even though its chemical properties like color and texture might change. Also, it is always written above the arrow in a chemical equation to show that it does not partake in the reaction. A catalytic reaction can either be homogeneous or heterogeneous. In homogeneous catalysis, the reactants, catalysts, and products are always in the same phase or physical state. Example is the oxidation of sulfur 4 oxide to form sulfur 6 oxide in the presence of nitrogen 2 oxide. In this reaction, the reactants, catalysts, and products are all in the gaseous state. In heterogeneous catalysis, the reactants, products, and catalysts are not always in the same physical state. Example is the same reaction between SO2 and oxygen to form SO3, but in the presence of vanadium 5 oxide. You can see here that while the reactants and products are in the gaseous state, the catalyst is in the solid state. Most catalytic reactions are heterogeneous catalysis. Other common examples are the reaction between nitrogen and hydrogen gases to form ammonia gas in the presence of finely divided iron, the hydrogenation of vegetable oil in the presence of nickel, otherwise known as the hardening of oil, used in the industrial manufacture of margarine, the reaction between hydrogen and iodine to form hydrogen iodide gas in the presence of platinum, and the catalytic oxidation of ammonia to form nitrogen 2 oxide and steam in the presence of platinum rhodium catalyst, which is applied in the industrial manufacture of triazonitrate acid, HNO3. To learn about redox reactions, watch our videos on redox reactions by clicking on the thumbnails at the end of this tutorial or check their links in the description. Note that a given reaction can fall into 2 or more types of reactions. For instance, the catalytic decomposition of hydrogen peroxide can both be classified as a catalytic reaction and a decomposition reaction. Similarly, the combustion reaction of carbon can also be classified as a combination reaction. So if this video was helpful to you in any way, kindly drop a comment and give us a like. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. You can also click on the join button to join our membership club, where you have access to exclusive videos, live chat rooms, and live tutorials where you can ask questions on any challenging topic, especially in chemistry, and will be answered. You also have the privilege to suggest topics that we can make tutorial videos on. A wise man once said, if you have integrity, nothing else matters. And if you lack integrity, nothing else matters. So always stay true to yourself and others till I see you when I'll see you.